Welcome to the Explainer. You ever stop and think about how a video game knows you just beat the final boss? Or how an ATM can tell you insufficient funds? It all boils down to one thing: making decisions. So today, we're going to dive deep and break down exactly how computer programs make these choices, and we'll be using the powerhouse language, C++.
You know, when you really get down to it, they're all just questions. That's it. Programs are just constantly asking little questions and then acting on the answers. Is the player's health at 0? Is this person over 18? Is the gas tank empty? The real magic, the secret sauce, is in how they respond to those answers. So come on, let's pull back the curtain and see what's really going on.
Okay, so here's the game plan for this explainer. We're going to start with the most basic, simple decision a program can possibly make, and then we're going to build on that step by step until we're writing some really smart, tough code that can handle just about anything. All right, let's do this. So, the fancy term for all this is conditional logic, but really, you can just think of it as the brain of your program. It's the part that lets your software be flexible, to react and adapt on the fly. It's what stops it from being a dumb machine and lets it respond differently to whatever you throw at it. All right, every journey has to start somewhere, right? Well, in the world of programming decisions, that first step is the simple if statement. It is the absolute rock-bottom, fundamental building block for everything else we're going to talk about. Now listen close, because this is the key. An if statement only has a plan for yes. That's it. Think about it like this. If it's raining, then I'll grab an umbrella. Period. Notice it doesn't say a single thing about what to do if the sun is shining. It only cares about the yes case. Just look at this. It's so simple, but it's powerful. The code is just asking one little question. Hey, is the number stored in this age variable 16 or more? If the answer is yes, and only if it's yes, it runs the code inside those curly braces. And in this case, all that does is print "you can drive" on the screen. Simple as that. Okay, but here's the big question, right? What happens if the condition is false? What if the age is like 15? Well, with just a simple if, the program does absolutely nothing. Seriously, it just skips right over that code block and keeps on going. And that's not always what we want, is it? Which, of course, brings us to our next tool.
So how do we deal with the no? We need a plan for when things don't go the way we checked for. We need to give our program a choice, a fork in the road.
And this slide just lays it out perfectly. On the left, you've got the basic if. But look at the right. We've added this new keyword, else. This one little word creates that fork in the road. Now, the program has to pick one of those two paths. It can't just ignore the whole thing anymore. So, by tacking on that else block to our driving age example, our little program just got a whole lot smarter. Now, when the age is 15, the first if part is false, so the program just hops right down to the else and does what's in there. In this case, printing, "you cannot drive yet." See? One question, but now we have two totally different, clearly defined outcomes.
If-else is great. I mean, it's perfect for those black and white yes or no choices. But let's be real, life is usually more complicated than that, right? What do you do when you have 3 or 4 or a whole bunch of different possibilities?
Okay, let's picture a real-world situation. Imagine you're writing the code for the welcome screen at a restaurant. It's not just about whether you can drink or not. There could be different rules for different ages. This is what we call an if-else-if ladder. And I love this analogy. Think of it like a waterfall. The program starts at the very top. It asks the first question, is the age 21 or more? If the answer is yes, boom, it does that thing and the whole process stops. But if the answer is no, the logic falls down to the next level, the else if, and it keeps falling down checking each condition until one of them is true, or it hits that final else at the very bottom, which is like the safety net that catches everything else.
All right, so now we've got the basic building blocks down. If, if-else, if-else, if. Now it's time to level up a bit. Let's add a layer of smarts to this so we can make our code not just do more, but be safer and more reliable too.
This is where we learn how to ask more than one question at once inside a single if. Instead of just checking one thing, you can check if this and that are true, or if this or that is true. It makes your code way more specific and, honestly, a lot cleaner. Okay, check this out. It's a super easy way to remember the difference. The AND operator, those two ampersands and, well, with that one, both things have to be true. You only go outside if the sun is shining and there's no rain. Both.
But with the or operator, the two vertical bars, or, only one of them has to be true. You'd go outside if the sun is shining or if there's no rain. See the difference? It's a huge one.
Now, this is maybe one of the most important things we'll talk about. Writing good code isn't just about the happy path, when everything goes right. It's about planning for when things go wrong. And trust me, they will. We call this defensive programming. In the real world, this is non-negotiable. Because if you don't plan for the unexpected, like a user typing their name instead of their age, your program can crash. And a crash can be anything from a minor annoyance to a massive system failure or a huge security hole.
So this whole idea is about building software that can take a punch, that's resilient and doesn't just fall over. And guess what our number one tool for this is? You got it, conditional statements. You can use a simple if statement to check a user's input before you try to use it. Is it actually a number? Is it in the right range? This one check can prevent all sorts of disasters, like the classic divide by zero error that can bring a whole system down.
Okay, enough theory. You've seen the tools, you've learned the concepts. Now it's time to put your skills to the test. I've got a mission for you.
Here's the situation. You're the flight engineer. Your spaceship is drifting in the void, and you're about to make that final jump to get home. Your job is to write the code that checks the fuel tank and tells the captain our status. You'll get the fuel level, and you need to output the right message based on these three conditions.
Now, before you start coding, here's a pro tip, a little hint right from the source material. Think about that if-else-if waterfall we talked about. The order you check things in matters a lot. So if your first check is the fuel over 1,000, and your next check is it under 500, think about what that means for any number that gets past both of those. You can let the structure of the code do some of the heavy lifting for you. All right, your mission is waiting. Can you code your way home? That's it for this explainer, but the big takeaway is this. With if, else, and else if, you now hold the keys. These are the fundamental tools that let you control the flow of a program. You can guide it, make it respond, make it react. You're not just writing instructions anymore. You're building programs that can, in a way, think. Good luck out there and happy coding.